In the coming lectures, we are going to talk about object-oriented programming. So, as we learned earlier, object-oriented programming is a methodology to design a program using classes and objects. Object-oriented programming concepts make it possible to reuse code without creating security risks or making a Java program less readable. It allows us to create specific interactions between objects. So these are the main characteristics of object-oriented programming. A class is basically a blueprint from which you can create an individual object. So when we instantiate a given class, this is when we end up with a given object. The object is an entity that has state and behavior. An object can be defined as an instance of a class. And this is what we have been talking about as far as memory management is concerned, that whenever we instantiate a class, we create an object on the heap memory. So every object is present on the heap memory. Okay, so there are four main principles of object-oriented programming: inheritance, polymorphism, abstraction, and encapsulation. So first of all, let's talk about inheritance. When one object takes all the properties and behaviors of a parent object, it is known as inheritance. When you inherit from an existing class, you can reuse methods and fields of the parent class in the child class. So the parent class is the superclass, the child class is the subclass. You may pose the question that why is it good? Because it provides code reusability and it provides code readability. So for example, we have a parent class with a protected string field name and a public void method. Then in the child class that extends the parent class, we can reuse the methods and fields of the parent class. Of course, new methods and fields can be defined as well, but what's crucial that we can achieve code reusability. So this is inheritance. What about polymorphism? This concept refers to the ability to perform a certain action in different ways. It can take two forms. We have method overriding. It occurs when a child class overrides a method of its parent. A method overloading happens when various methods with the same name are present in a class. So method overriding is called runtime polymorphism when we have a protected void method and in the child class we are able to override that given method. This is called runtime polymorphism. And we have the compile time polymorphism, basically method overloading, when we can create the same method with different parameters. So this is called method overloading. And the objectives are that it provides code flexibility and better implementation of inheritance. Okay, what about abstraction? It hides complexity of data and shows only the relevant information, gives flexibility to programmers to change the implementation of the abstract behavior. There are two ways to achieve abstraction: with the help of abstract classes or with the help of interfaces. It provides flexibility of implementation, code readability, and multiple inheritance. So we can use abstract classes and we can use interfaces in order to achieve abstraction. What about encapsulation? Binding or wrapping code and data together into a single unit are known as encapsulation. It restricts direct access to data members, so field variables of a given class. You can implement encapsulation in Java by keeping the fields or class variables private and providing public getters and setters. So with the help of getters and setters, we are able to manipulate these variables. Why is it good? Because it provides code readability and data protection. So for example, we have a given class, encapsulated class, with a given field variable, the private string name, and with the help of getters and setters, we are able to return the name and we are able to change the value of the name variable. So this is called encapsulation. So these are the four pillars of object-oriented programming. In the coming lectures, we are going to talk about inheritance, polymorphism, encapsulation, and abstraction on a one-by-one basis. Thanks for watching. In this lecture, we are going to talk about the concrete implementation of inheritance. So for example, we have a parent class, so the parent, and we have a child class, so we have a child, and the child is able to extend the parent. This is called inheritance, which means that if we define a given protected void method, and for example, it's going to print out that this is a method of the parent class, okay, and we are able to call this method from the child class. So if we search for the method, as you can see, we can override a method that's present in the superclass. What's crucial that if we make this method not protected but private, then the child class is not able to override it. So as you can see, the method of type child must override or implement a super type method. So in this case, we are not able to override the method we have defined here in the parent class. So this is why it needs to be protected. Okay, so in this case, we are not going to override, but we are going to create a protected void child method, and it's going to print out that method in the child class or something like this. So as far as the parent class is concerned, this is the method of the parent class, and sorry for it, it's going to be a parent method. So we are able to do something like this, that we instantiate a child is equals to a new child, and here we are able to call the child.parent method. So as you can see, because the child class extends the parent class and the parent class has a protected parent method, this is why if we instantiate the child, then we are able to call the parent method, and of course we are able to call the child method. So if we save and run the application, this is a method of the parent class and this is a method in the child class. So this is called inheritance, that the child is going to extend the parent class, which means that the child is going to inherit the methods and the instance variables of the parent class if we declare it to be protected. Okay, so this is inheritance. We can define multi-level inheritance. So if we create a new class, grandchild, and it extends the child, then because the child extends the parent, we can say that the grandchild extends the parent as well. So here we will have a protected void grandchild method, and we print out that method in the grandchild class. And if we instantiate this grandchild, so in the application, we can instantiate the grandchild. So grandchild, new grandchild, then we are able to call the method of the child. We can call the method of the parent, and we can call the method of the grandchild. So if we save and run the application, this is what's happening here. Method in the child class, this is a method of the parent class, and a method in the grandchild class. So of course we can call this grandchild method because we instantiated a grandchild object. But what's crucial, that because the grandchild extends the child and the child class extends the parent, that's why we can access the parent related method after instantiating the grandchild. So this is called multi-level inheritance, that the child extends the parent, the grandchild extends the child, and this is why the grandchild is basically a parent as well. So this is why it is able to access the methods defined in the parent class. So this is called single level inheritance, or just inheritance. This is called multi-level inheritance. We can do the same with interfaces. So if we have a interface 1, we have another interface, so interface 2, and we have a third interface, interface 3, then we can say that the interface 1 has a method public void interface method 1. So this is the method we define in the first interface. Then we can do the same with interface 2, of course, interface method 2. And then we can say that the interface 3 extends the interface 1 and interface 2. And basically this is the reason why interfaces are extremely crucial, because we are not able to extend multiple classes. So for example, if the grandchild tries to extend the child and the parent, then there is no multiple inheritance in Java. So we are not able to extend multiple classes, but we are able to extend multiple interfaces. So this is why if we have interface 1, interface 2, and interface 3 extends the interface 1 and the interface 2, then it is going to work just fine. So if we have another class, for example, multiple interfaces, okay, with some typo, sorry for that. Anyways, what's crucial that if it implements the interface 3, then we have to override the methods we have defined as far as interface 1 and interface 2 are concerned. Why? Because interface 3 extends these interfaces. So this is why we have to deal with the methods defined in interface 1 and the methods defined in interface 2. So this is why we have to override these methods. So I print that this is coming from interface 1 and this is coming from interface 2. So whenever I save it and instantiate a new multiple interfaces like this, then we are able to call the multiple interfaces.interface method 1 and multiple interfaces.interface method 2. Why? Because this multiple interfaces class implements the interface 3, but the interface 3 extends interface 1 and interface 2 that contain these methods. So these are the methods we override. So this is how we can achieve multiple inheritance with the help of interfaces. And what's extremely crucial, that we can extend multiple interfaces, while on the other hand, a given class is not able to extend multiple classes. So this is why interfaces are extremely crucial. And of course, a given class is able to extend a given class and implement a given interface. So if I create a new class, hybrid class for example, then it is able to extend the parent class and it is able to implement the interface 3. So in this case, of course, we have to override the interface method 1 and interface method 2 because of this interface. And we are able to use the methods we have defined in the parent class. So the parent class has the protected void parent method. So this is why in the hybrid class, we are able to override the parent method. So I'm going to print out that this is the parent method. Okay, here we print out that interface method 2, and here we print out that interface method 1. Okay, so if I save it and in the application I instantiate a hybrid class, okay, is equals to a new hybrid class, and we are able to call the methods we have defined. The interface method 1, we are able to call the interface method 2, and we are able to call the method we have defined in the parent class. As you can see, the parent method. So if I save it and run it, then these are the methods we have defined. So this is how we can achieve inheritance with the help of classes and with the help of interfaces. Thanks for watching. In this lecture, we are going to talk about polymorphism. So I'm going to create 3 classes. The first class is the child class. The second class is the parent class. And we are going to use another class, the so-called grandchild. And the parent is going to have a protected integer h parameter, which is equals to 50. And it has a protected void travel method. And we print out that parent is traveling. Okay. We have the same methods and same variables here. So we have protected integer age is equals to 10, and we have a protected void travel method. Here we print out that grandchild is traveling. Okay, and we have approximately the same here. We have a protected integer age is equals to 30, and we have a protected void travel method again. So we print out that the child is traveling. Okay, so these are the classes we are going to use, and what's crucial that the child extends the parent and the grandchild extends the child. So if we use something like this, because the grandchild extends the child and the child extends the parent, we can say that child is a parent and grandchild is a parent. So we are able to use something like this. Parent P1 is equals to a new parent. Of course, we can do it without any issue. But we can do something like this. The parent P2 is equals to a new child. So because the child class extends the parent class, this is why we can instantiate a child as a parent. And because the grandchild extends the child, which is a parent, we can use parent P3 is equals to a new grandchild. So something like this. And we can call the travel method without any problem. So travel and P3 travel. So if we run the application, then parent is traveling, child is traveling, and the grandchild is traveling, which means that, as you can see, the references are all parents. The newly instantiated classes are parent, child, and grandchild, but if we call the same travel method, then the travel method of the parent class is going to be called, the travel method of the child class is going to be called, and the travel method of the grandchild is going to be called. The problem is that in Java we can override methods only, not the variables. So runtime polymorphism cannot be achieved by data members. So what does it mean exactly? That if we print out the p1.age and we do the same for P2 and P3, if we run the application, then all of the integer age values are going to be the value of the parent. And this is why we have discussed that in Java we can override methods, so it is working fine for methods, but it is not working fine for variables, because if we instantiate a new child and we get the age parameter, then the age parameter of the child's superclass, so the parent age parameter, is going to be printed out. And this is true for grandchild, because grandchild is a child and the child is a parent. Again, if we print out the grandchild, so p3.age value, again the parent's age value is going to be printed out. So in Java we can override methods, but we are not able to override variables. So what can be the solution? The solution could be avoid polymorphism. So if we instantiate a grandchild like this, so grandchild, for example, G is a new grandchild, and we print out the g.age parameter, then in this case it is going to work fine, and we print out the age value of the grandchild, which is 10, as you can see. So it is working fine. So it is crucial that we can achieve polymorphism because of inheritance. So because a child extends the parent class, this is why we can instantiate a child like this, that a parent P2 is equals to a new child. We can do the same with multi-level inheritance, because grandchild is a child and the child is a parent. Again, we can instantiate a grandchild like this. We can override methods, but we are not able to override variables or data members. If we want to use the variables for the given class, then we have to instantiate it explicitly like this. So that's all about polymorphism, method overwriting, and variable overwriting. Thanks for watching. In this lecture, we are going to talk about encapsulation. So just to summarize again, Binding or wrapping code and data together into a single unit are known as encapsulation. The objective is to provide code readability and data protection. So if we create a new class, for example, person, then we are able to create private field variables. So a private string name and a private integer age. So in this case, we are going to use the person as a wrapper class in order to store the name variable and the age parameter with private access modifiers. So for example, we use a constructor. In the constructor, we do nothing, and we are going to create getters and setters. So we source, generate getters and setters for the age parameter and for the name parameter. So this is how we can create the getters and the setters. And as you can see, basically this is the basic concept of encapsulation. I'm going to override a toString method, and here we return person plus this dot age plus some spacing and this dot name. So whenever we create a new person object, so person p1 is a new person, we can use the getters and the setters in order to set the age, for example 22, and in order to set the name, for example Adam. So if we print out the person object, then the toString method is going to be called. So this is why we have created the toString method. So whenever we print out a given object, then the toString method is called, and the result is a person with age 22 and name Adam. What's crucial that we can do something special here. So for example, we check that if the age parameter is greater or equals than 0, this is when we set the age parameter. This is how we avoid that the user will use a negative value for the age parameter. So in this case, it is going to work exactly the same manner, but if we use -22, then this -22 is not going to be used. 0 is the initial value of integer field variables. So whenever we create a private integer age, then whenever the new class is instantiated, then Java is going to use 0 as the initial value for the integer. So this is why maybe it is not the best solution possible. What's good that if the age is smaller than 0, then we throw a new exception. So in this case, we throw a new illegal argument exception, and we specify that the message is the age parameter cannot be smaller than 0. And else we set the age parameter to be the age parameter. So in this case, whenever we use, for example, 56, then it is going to work just fine. And whenever we use -10, then Java will throw an illegal argument exception that the age parameter cannot be smaller than 0. As you can see, it is a runtime exception because the user provided an age parameter that's smaller than 0. So this is how we can deal with encapsulation. What's crucial that you can implement encapsulation by keeping the fields, so the class variables, private and providing public getter and setter methods. So that's all about encapsulation. Thanks for watching. In this lecture, we are going to talk about encapsulation and mutable objects. So if we create a new class, cars, and this class is going to store a private list of strings, for example, cars. First of all, let's import java.util.list, and then let's create a source, generate getters and setters for the car list of strings. In this case, it is called encapsulation, that we have a cars class that has a private field variable, a list of strings, and we can get the list of strings and we can set the list of strings with the help of getters and setters. So let's create a new list of cars, a new array list, and I'm going to add, for example, Honda cars.add, for example, Ford. Let's add Mercedes and just for demonstration purposes it's going to be fine. What's crucial that we are able to instantiate the cars class, so a new cars, and of course we are able to set cars and provide this cars list of strings. Okay, sorry for that, we have the same variable name, so it's going to be the cars class set cars. And in this case we are able to iterate through, so strings cars class dot get cars, and we print out the given string. So it is going to work just fine. We instantiated a list of strings, Honda, Ford, Mercedes. We use the setter method in order to inject a list of strings, and we store this list of strings in a private field variable. It is going to work just fine. We iterate through the cars class.get cars, which is a list of strings, and we print out the value. What's crucial that we are able to modify the value of this list. So if we do something like the list of string actual cars is equals to the cars class dot get cars, and we add another value, for example BMW, and then again we iterate through all the values of that given list, then in this case, okay, I use a new line character to be able to separate the results, but as you can see we have managed to insert a new value, and it is because the fact that lists and array lists are mutable objects, which means that we are able to change the value of the given array list. It is not the same with strings. This is what we have been talking about, that string objects are immutable. We are not able to change the value of a string after we have created it. Lists and array lists, on the other hand, are mutable objects, which means that as you can see, we have created the given list, we injected into the cars class, and then we get the cars and we updated the list and add another value BMW. And there is no need to call the cars class dot set cars and we specify the actual cars. As you can see, if we do something like this, of course we know for certain that the list is going to be updated. But if we do not do something like this, the list is going to be updated anyways, because lists and array lists are mutable objects. So this is why it is a good programming practice that whenever we get the cars, as far as the cars class is concerned, we are not going to return the actual list, but we are going to return new array list, and here we specify this dot cars. And in this case, what's going to happen? Whenever in the application.java we get the cars, a new array list is going to be returned. So whenever we update the value and we add a new card type to that given list, the list we store here is not going to be changed because we returned a different array list. So in this case, no matter that we add BMW, we rerun the application, and as you can see, the original list hasn't been changed. So this is why we have to be very, very careful when dealing with lists and array lists, because they are inherently mutable, which means that if we get the given list and we add the new value, then the original list is going to be changed here. So this is why it is a good programming practice that whenever we get the list of strings, in this case the cars, we return a new array list, and of course we make sure that this new array list contains the same values as the original list. But this is how we can make sure that whenever the user updates that given array list, then this change is not going to be reflected in the original list. Thanks for watching. In this lecture, we are going to talk about Java beans. Java beans, or also known as POJOs, so plain old Java objects. Java beans are classes that encapsulate many objects into a single object, the bean itself. Java beans should follow the following conventions. It must implement serializable interface. It should have a public zero-argument constructor. This is called a default constructor. And all properties must be private. So these are the instance variables of the class. And we have to allow access to properties using getter and setter methods. So for example, if we have a class, name is going to be Java Bean example. For example, we have the private string name and the private integer ID of the given bean. We have to make sure that it's going to have a default constructor, so without any argument, and we have to make sure that it is going to have getters and setters. So let's generate getters and setters for the ID and for the name. And I'm going to override the toString methods, so whenever we print out the object itself, then we are going to print out the name and some spacing and the ID. Okay, so let's save it, and in the application.java we are able to instantiate a new Java Bean example, new Java Bean example, and we are able to set the given properties such as the ID is going to be 1 and the name is going to be Java Bean 1. Okay, so if we print out this Java Bean example, then it is going to work just fine. We have the name and we have the ID. Of course, we should make sure that the class implements the serializable interface. So in this case, it is working fine, but it is not a Java Bean because a Java Bean implements the serializable interface. We are going to talk a lot more about the serializable interface, but as you can see, serializability of a class is enabled by the class implementing the java.io serializable interface. Classes that do not implement this interface will not have any of their states serialized or deserialized. So basically, a given class that implements the serializable interface can be used with streams, for example, or if you want to save the state of a given class, then you have to make sure that the class implements serializable interface. Anyways, what's crucial that beans implement serializable interface, and in the coming lectures we are going to talk a lot more about this interface. So that's all about a Java Bean. A Java Bean implements the serializable interface. It has a default constructor, it has private instance variables, and we have getters and setters in order to get and in order to set the given instance variables. So that's all about Java Beans. Thanks for watching. In interfaces, so originally an interface could only have abstract methods, but after JDK 8, changes have come, which means that the interface body can contain abstract methods, default methods, and static methods as well. So if we create an interface, for example, modern interface, then here we can define several methods. Let's define a public void abstract method. It is going to be the classic interface method, so the so-called abstract method. But after JDK 8, we are able to define a static method within a given interface. So we have a public static void static method. Okay, and we are not able to use a semicolon because there's going to be a compile time error. This method requires a body instead of a semicolon. So we are able to, just for demonstration purposes, I print out that this is a static method in the interface. ... Okay, so this is how we can define a static method within an interface. So let's use the command static method. And finally, we are able to define a so-called default method. So public default void default method. And again, we have to define the body. So just for demonstration purposes, this is a default method in the interface. Okay, so this is how we can define a classical abstract method without a body, as you can see. Then we can define a static method, and here we have to define the body of the method. And finally, we are able to define a default method. Again, we have to define the body itself. So this is a default method. So if I save it and let's implement this interface, so the application class implements the modern interface, and if we save it, as you can see, we have to add the unimplemented methods, but basically we have to deal with the abstract method exclusively. So we don't have to override the static method, we don't have to override the default method, we have to override the abstract method exclusively. Okay, so let's use something like abstract interface method from the application class. And here we can use something like, first we have to instantiate the application class, so new application, and first of all we are able to call the abstract method. So if I save it and run it, then this method is going to be called, so abstract interface method from the application class. We are able to call the static method because it is static, there is no need to instantiate anything. So we can use something like modern interface dot static method. We can call a static method present in an interface just like we are dealing with classes. So if I save it and run it, this is a static method in the interface. And finally, we are able to call the default method. So as you can see, we are able to do something like this, application.default method. So the method within a given interface that defined default, it means that we don't have to override that given method, but we are able to call it as far as the given class is concerned that implements the given interface. So in this case, we can run all the methods. So as you can see, this is a default method in the interface. So as far as abstract methods are concerned, we don't have to define the body of that given method and we have to override it as usual. As far as the static method is concerned, we have to define the body of the given method and we can call it like this. And as far as default methods are concerned, we have to use the default keyword. We don't have to override that given method, but we are able to call it like this. So these are the three main types of methods within a given interface. What's crucial that we are able to override the default method. So with default functions in interfaces, there is a possibility that a class is implementing two interfaces with the same default method. The first solution is that we can override it. The second solution is that we can call the default method of the specified interface using the super keyword. So I'm going to create another interface. Let's call it another interface. And within this interface, I will have the exact same method as here. So I'm going to copy and paste the method here, public default void default method. And here I print out that default method from another interface. Okay, so if I save it, then the application class is going to implement this another interface. So what's crucial that after implementing another interface, then we have to override the default method. So if we override, for example, like this, then another interface.super.default method is going to be called. This is why we have been discussing that we have to use the super keyword. So Java has to know whether we are going to call the default method present in the modern interface, so this method, or present in another interface. So this is why we have to override the default method, and in this case we are going to call the another interface related default method. So if I save it, then whenever we call application.default method, then default method from another interface is going to be called. We can do the same with the modern interface. So if we use modern interface.super.default method, we save it and run it, then in this case this is a default method in the original modern interface. So that's all about abstract methods, that's all about static methods, and that's all about default methods as far as interfaces are concerned. Thanks for watching.